All right. Welcome back, everyone. This is Devashi here. In the last video, we have seen what's the difference between packages, library, and a distribution. What are virtual environments and their importance? Problems with sys.path extend method, and what's the standard way to distribute a package? Next, PyProject.toml syntax. Um, if you're still confused about some of this, it'll eventually get cleared in the last video. So we'll do when we cover the 9th and 10th point, these 9 and 10 topics. So today we will see 6, 7, 8. We'll see how to use UV as a package manager. We have seen what a package manager is. We'll see, if not seen, creating virtual environments using UV and configuring the interpreters in VS Code. Okay, I hope you have installed VS Code in your computer, the Python latest version of Python, also the Git bash terminal. Okay, now let's before we proceed, we need to have UV in our machine first. Let's do this. Okay, we can directly see how to install UV. From the Chrome, go and type, and depending on your OS, you can install any thing. We have so many ways here, but we'll pick the most easiest one. Okay, we'll install using Python itself, Python package manager itself, the default Python package manager itself. So, okay, get ahead to command prompt. Okay. Next, which Python? Oh, which is not working. Okay, so go to command prompt and type pip install UV. Okay, I have already installed the UV in my system. Hence it shows already installed at this location. Okay. If you have already installed, then let's upgrade it to the latest version. It has been a long time I installed UV. Let's upgrade it to the latest version. Pip install upgrade UV. I hope you have studied what is the difference between source distribution and wheel distribution, and this shouldn't confuse you at all. This .whl file. Anyway, we'll see this while distributing our package in the last video. Next one. So now I have installed the UV in my computer. By the way, if you okay, there is a chance that you might think that UV is a library. Basically not. The pip, so this is a Python's default package manager. What is a package manager? We saw last time. Okay, this is package manager. So this is something that lets us. This is a package manager is something that lets us to manage the dependencies. It lets us to distribute our projects, and it does a lot. Basically, it also allows us to create the virtual environments and so many things. Pip is the default Python package manager. So there is another package manager which we have just installed, that is UV. Okay, UV is an application. This is not a library. Basically, whenever you type pip install something, this something can be categorized into 3 categories. Either it is a package or a library. Okay, it can be a package or a library, like NumPy, Pandas, Jack, SciPy are the good examples for it. It can be a CLI application. The most famous ones, or the most the examples for it are AWS CLI. No, see this one. This one's AWS. So this one. AWS CLI, AWS commands. It's like there is a CLI application which is installed in my machine that lets me to execute this command. So this AWS CLI is one of the application. Ansible, which is used for configuring the servers. This is another CLI application which can be installed using pip install. Uh, Also, UV, the most modern package manager, the ultra fast modern package manager, Python package manager. This is an application. Another category is CLI tools. So these are mainly used by the developers for development purposes. Rough and Poetry are the good examples. So yeah, you can install with the Python package installer. You can install a package or a library which you can import in your projects. Now, by these are the examples for it. It can be a CLI application like the one that we just installed here, UV, and it can be a CLI tools. Okay, this is not that important. I just wanted to tell you because I used to get confused uh, long time ago whenever I install UV because I was trying to import like desktop UI import UV when uh, something I will get this. Okay, fine. And that is a CLI application. Don't treat it as a package or a library. Next one, yes. So with this, let's initialize a Python project using. Okay, take go to any empty folder. Okay, just go there. By the way, so to manage anything with the global Python, if we are managing the packages for the global Python, we will use pip. If you are specifically in the Python project, in a specific Python project, we'll use UV as a Python package manager. Now, if you want to initialize a project, let's say if we want to initialize a project, so we will type UV init and limit. So this creates us the 4 files. Python version. So this indicates the current Python interpreter version used in our project. Main.py, this is a just created as a main file of this project. Then pyproject.toml, you know it. Then readme file, basically a description of our project, anything we want to describe about our project. Eventually in the this readme.md eventually goes to github's readme.md. The next, okay, now this is how you initialize a project. Let us say you want to change the Python version that is being used. To do this, let's initialize one more. Let me remove everything here. UV init, if you want to initialize the Python project with a specific Python version, like you can mention it 3.14. So now you have Python version as 3.13. Something is up. UV. Let me check this. UV init. Python, I want it to be 3.12. Okay. UV Python install 3.14. Sorry. Wait a minute, I'm figuring it out what went wrong. Remove recursively by force everything. UV Python remove recursively by UV init Python 3.14. Let us say I remove everything and UV init Python 3.12. Python 3.5. Okay. Um, it looks like I haven't deleted the .python version file uv in it earlier. So if I have 3.13 here and I remove everything, since it is a hidden file, since it is a hidden file that starts with dot, the file name starts with dot, it is considered as a hidden file. So it wouldn't have got removed at that time. uv init python, maybe I will say it one bit. Okay, fine. You will get 3.10 here, but this Python version. So if you want to change this file, either you go directly and change it, or you can say uv python pin 3.13. Okay, you can change that this way. So basically, this is for the UV tool to figure out which version of Python that the project is currently using. In pyproject.toml, you would specify that it is any version greater than or equals to 3.10 is okay. But which version of Python this project is currently using, that is determined by .python version. If you want the project to use 3.14, then you can write uv python pin 3.14. It will change to 3.14. So it means if even if you have 3.10 here, uv will install the Python interpreter that is of 3.1. Okay. Now let's create a virtual environment for our project. You know why do we need a virtual environment for our project? Okay. So to create a virtual environment, just type uv virtual environment. So this command looks at the Python version of your Python version file of your project, and it creates a Python interpreter with 3.14. So if you want a different version, there are two ways. Either you go and directly change this uv python pin. Let's say I want 3.13. Change it to 3.13. It got updated there. So next uvvn. So now it installed 3.13.5. So there is another way also. uv.env. Let me remove the virtual environment created. You can say uv virtual environment. Hey, install a Python interpreter of 3.14. You can specify the while create uvvnv. I want the Python interpreter of version 3.14. Now you got the Python interpreter version 3.14 as it is specified here. Don't change, so to maintain the consistency, don't change it later. Okay, now let's take a look at .venv. You can name the folder, but okay, it's let's say we want to let's say I want to keep the project with the same name, the virtual environment with the name .venv only. It's more semantic to me. Now we see that we have a git ignore here. Fine. Okay, so it says ignore everything which is here. Okay, pyconfig env config something. Let's not get into that one. Main one are scripts. So you have the first one. This is activate script. The other one, you see these two, python.exe, python.w.exe. This is our interpreter. This one you see, this is our interpreter for our package. So last one time we saw, it's here. So we saw that our project will have a separate Python interpreter specific to this project. So that is here. To activate that interpreter, let's see my CLI, this command line tool. Command line interface. What actually, which Python it is using? To know which Python it is currently using, which Python. So you see that slash C Python 314 Python. This is my global Python. So to change my interpreter to the current one, so this project's interpreter, right? You have to do this. You have to take this one, this activate script, and source it. As it is saying, you can activate this virtual environment in your CLI using source, this command. Run this uv.venv scripts. You have a activate script. Source that script, then you will see that your virtual environment got activated. This is a clue for it. Earlier we were not having that UV demo. Now we have it. So this is a indication that the virtual environment got activated, and we can verify that using which Python. So now it is using C users. This is the current directory. In this directory we have a separate virtual environment. In that I said python.exe is the interpreter that is specific to this project, and now it is using Python scripts Python. You see it here. We can list it in a long format. Let me see it. Okay, so this one. Okay, let me clear out this. Now you have activated this. Let us say okay, now let's start writing our Python files. This is our main file. The print hello world. This is from unit demo. No. Okay, we have activated interpreter at the CLI. There are three interpreters. When you are in a Visual Studio Code, working with Visual Studio Code, they're basically I personally classify these interpreters into four different. Like you have to configure the interpreter at four different places. Or unknown. Okay, maybe you could find different file for it. Okay. Configure the interpreter at four different places. The first one is your CLI command line interface. This is the command line interface. We have done this. First one will be by sourcing the .venv dash scripts slash activate. So the second one is Pylance interpreter. So the VS Code Pylance. This is for VS Code. Okay. And this is for like this we set it for VS Code's Pylance. So you see that let's say let me write on another file. This is an src folder. Inside that, let me write some files. Module 1.3. Okay. Okay. Number. Okay. So there is some interpreter. Okay. So there is VS Code has an like it selects an interpreter for evaluating all these parts. Evaluating. Let's say you made a syntax mistake, like if name equals to allow something print or something print this is main. This is something. So there is an interpreter which is running in VS Code. It is using some interpreter to decide that errors, to give you red squigglies, also to take this like teleport you to the package, right? So it is using some interpreter. So we should also set that interpreter to our current virtual environments interpreter. So now if you currently see, okay, I haven't installed in this library, I haven't installed any package. NumPy is not even installed. So instead of giving me a red squiggly here, it is taking me to the NumPy. And you see where it is located, C user studio app. You see, this is Python 3.14, this is global Python. So which means this current one is configured with the global Python. So the VS code is configured with the global Python. To change this, look at the bottom right corner of your VS code. Let me change the, you are unable to see it. This one. Now you can see it here. This one, you see, UV demo, something you have it here. Change the, select the interpreter to browse, then UV demo.venv library site packet scripts python.exe. Okay. Let me install UV. Okay, for path in this dot path, import this. For path in this dot path, print. Let's say I run Python module 1.py, copy path. There is no module. You can skip the video, by the way. Something is up here. Let's go. Reference, wireless networks, identity units. Read them. Okay. Python src. Okay, main. Okay, now I have restarted the VS Code. There was some, I think, yeah. Sometimes this is not too often, but it behaves weirdly sometimes. Yeah, interpreter was not working properly when I first selected. Now you see that we have selected the right interpreter here, and in the side packages you don't have NumPy, and hence it is showing, hey, NumPy package is not installed. It could not be resolved because you don't have it inside the side packages. Now, so we have configured this one. So to add a dependency. So now to add a dependency to our project. Now currently we don't have any dependencies here. So to add a dependency, you add. So dependency means what? It's a dependency. It's a package that your project depends on. Let us say my project depends on NumPy. And I'm adding NumPy. UV add numpy, it automatically edits your dependency section of project.yaml. Look at here, it is now installing very fast. UV add, let's say Jax is also there in my project. Jax depends on SciPy and JaxLib. It is automatically installing the dependencies that Jax has. So this is a very good advantage of having a package manager. This is we have seen this earlier. Let's see. This is what I talked about last time. The package management. So what if you're when you're installing a project, like when you're installing a package, what if that package already has some dependencies that will get automatically installed while you are using a package manager? See, we added a package Jax, and Jax internally was dependent on JaxLib ML types, obtain some SciPy, and the package manager resolved those dependencies automatically without our intervention, and it installed that for us. I only installed NumPy and Jax, but they are dependent on some other packages. They also got installed. This is a very good advantage of having a package manager. Second one, now let's say you want to add some other one. Let us say I also add rich. We see rich is dependent on market by MDL segments. So these are also got installed. Now, what if I want to, let's say I want to remove Jax as a dependency. So to remove the Jax as a dependency, just write UV remove Jax. You see, it got removed. Let me add it back. We add Jax. Let's say I also add UV add rich matplotlib. Yeah, and you see these are, it is downloading many things parallelly, and this is very fast. UV is a package manager written in Rust, a very fast programming language, and this does the work so fast. And this is one of the advantages of UV. No, I've written this here. What is advantages of UV? This is a very fast than the standard Python package manager. This is written in Rust, a popular programming language which is known for its super fast speed. It parallelizes the downloads during the dependency resolution. Efficiency dependency resolver. It resolves the dependencies much better than the standard pip. It automates the visual environment creation just with the command UV visual env. This is much better than doing Python -n virtual environment. This is a very tedious command. But with UV, you only type virtual environment UV and it takes care of everything. Next, efficient dependencies management during the development process using UV. We will see this now. Let's come back. No. Demo project, not this one. We were here. Okay. Let me clear out all this. Now, while you are installing packages, right? So you have added dependencies. These are the dependencies of your project, and what does UV log do? See, you are saying that hey, Jax, I want a Jax package or Jax library greater than or equals to the version 0.6.2. This means that, so if tomorrow if there is a version greater than version, let's say 0.6.3, there is a version 0.6.3, then if you do UV pip install UV pip install recursively by project.yaml, This will install that no maybe mm, this will install that 0.6.3. If there is a update, let's say today there is no update, my current package version is 0.6.2, but tomorrow, let us say when my friend, my fellow developer is working on the project, if there is an update from the jacks and they updated the version to 0.6.3, it will get updated to that one if you directly write this command ubpip install. Hey, look at the dependencies from the pyproject.toml and install all of them. And this can become a problem sometimes because the versions that you are currently using, maybe let's say you have a fridge 14.0. So the versions that you are currently using, there is no guarantee that your fellow developer will also use the same versions when they install it using UV pip install recursively from the requirement file is pyproject.toml. It will look into it and install maybe a 15.0. Here I am specifying which 14.0.0. It might end up installing 15.0. Okay, I have changed. I have changed the versions a little bit to highlight the importance of uv.log. Okay. Now I have installed. Let's say I manually installed a rich pack. This is the rich package. So I installed the version 14.0.0. You can see it here. UV pip show. You can run the UV pip show in my UV demo folder. This folder. I have installed the version 14.0.0, but the latest one is the latest version available is 15.0.0. Now let's say imagine a case where today the version is 14.0.0 and tomorrow when my fellow developer opens the project, the latest version was released and it is 15.0.0. Then when he installs it using normal requirements method, pip install requirements file pyproject.toml, what will he do? So I have just copied the readme file, all these files except the .venv and uv.log into a separate folder, created a different virtual environment there to make you understand it. Let us say we go to this one, uv demo. Now let me activate the virtual environment there. Interpreter, not the virtual environment. Now let us say UV pip show. So now this one doesn't have any libraries installed currently. Okay, so Python interpreter is the same one. Okay, let's install UV pip install. While you're using UV, always write pip installs with UV. Do not write pip install alone. Write UV pip install. UV pip install, the most common way, by UV pip install from the requirements file project.toml. Look all the dependencies inside the project.toml and install them. Let's see what does it do. So as I said, it installed rich 15.0.0, but the current version I was using there was only 14.0.0. Now it is using 15.0.0. You can verify this. Pip show 15. Pip show rich. Now this is a problem. Then the latest update might have changed something, and my friend would say, "Hey, bro, it's working. It might be working on your computer, but it's not working on my computer. Something is up." So we need to invent a method, or we need to figure out a way so that everyone working in the team gets the same version while working, regardless of this one, or regardless of this dependencies one. They should be able to have the same version of the package in all the computers that developers have. So The answer to this, the method to this, is uv.log. So this one, uv.log, what does it do? It logs all the versions that you are using. Okay, you have specified any version greater than or 14.0.0, and you have specified any version greater than 0.6.2, it's fine. But I will log the current versions that you are currently using on your computer. This developer, maybe I'm developing the project currently. Whatever the versions I am using, that versions will be logged by the uv.log. And when I share this to my fellow developers through the GitHub, they will get these files. Let me copy this Python version main.py uv.log. Let me copy along with the uv.log and go there. Clear. Let me create the virtual environment here again. I have deleted it. UV demo 2, it's src. What happened? Okay. Are these in src? Okay, let me check it once. I should not put them in src. I should put them in this one. Okay. It's fine now. Let me pull the uv.log to outside. Okay. Let me create a UV virtual environment. No, let's not create anything. Okay. You have uv.log here. You have pyproject.toml saying rich 14. You have a uv.log, everything fine. Now, what will he do when he receives the project or he clones the project from the GitHub? He will not do anything. He will not create a virtual environment. He will not do anything. He will just run uv sync. The only command you have to run when you get a Python project, just run uv sync. Let me deactivate. Okay. Now you don't have any virtual environment got activated, anything. Just run uv sync. That's it. Okay. First, it looks at your Python version and installs a interpreter for you, creating virtual environment. You see it here, library, or not library, scripts, python.exe. It will install the python.exe file with the version specified by .python version. Then it looks at the dependencies file once and also looks at the uv.log and installs those versions which are specified by the uv.log. Now you see we have we have the rich 14.2.2. Now my fellow developer will have the same versions that I have, and that's only possible because of uv.log, because it has logged the versions and shipped it through the GitHub. Okay. Now that's the advantage of uv.log, and I've mentioned the same here. Efficient dependencies management during the development process using uv.log. It avoids, hey, it works on my computer, why doesn't it work on you? So that is basically because of version mismatches. And that version mismatches we are avoiding here. Okay, then you might ask a doubt here. You should get this doubt. Hey, Devarshi, what if okay, this is not the one. Okay, this is our project. Okay, let me delete all of this. Hey Devashi, what if you want to upgrade the packet? You want to upgrade the what? You want to upgrade the versions of your, what should I say? You want to upgrade the versions of the dependencies that you are having. Let us say I want jax exactly equals to 0.6.2 or maybe 1. How would I do this? So one thing is, if you want a different one, you change the dependencies file, UV, then run UV sync. Say 0.sync can't be because it has a source of current platform you're using. Okay, let me change the interpreter version. Let's say 3.13. So because of this error, I'm changing the interpreter version, and let me delete this. Okay. Now I'll run UV sync. This will automatically take care of it. Wait. Earlier I was having this one greater than or equals to 0.6.2. Let it do everything. Now I want to let us say to change the package, you can do 0.6.1 maybe, and let's say you write UV sync. So this looks at the dependencies. First it looks at the dependencies, then it looks at the uv.log, and it tries to match the version somehow. So uv.log have 0.6.2, but the dependency says I want exactly 0.6.1, and hence it is now it resolves the dependencies to 0.6.1 and updates the uv.log. You can see it, uv if show that's it updates here. You can also see inside the uv.log jacks. Okay, name package, you have the package version 6.1. The other one, so this is how you upgrade or change something. Maybe you want anything greater than 0.6.1, then you can change it here. UV UV sync. So UV sync looks at your first, it looks at your dependencies, then it looks at your uv.log, and it tries to resolve. So this is saying I want anything greater than 0.6.1, and uv.log has 0.6.1, greater than or equals to 0.6.1, and uv have that. So it's okay, fine. The dependency says this and uv.log version says this, fine. I need not to upgrade it. It's okay that it has this. Now how do you upgrade it? Upgrade to the latest versions. The way to upgrade to the latest version, let's say tomorrow there now you have a latest version 0.6.2, and you have a latest version here, you have latest version 15.0.2. How would you do that? Then to upgrade that, just write uv.log uv.log upgrade. If you want to upgrade a specific package, you can write uv.uv what uv upgrade jacks upgrade package jacks. Okay, I have wrote a wrong command. uv.log upgrade jacks. So it has upgraded to what did it do? UV pep show jacks. It has okay. To propagate this upgrade, you must write UV sync. So now you have jacks 0.11.0, 0. Jacks label also 0.11.2. So we have upgraded it. What if you want to upgrade all the packages inside it? To do that, you have to write uv log. You're saying you're upgrading the uv log file. Uv log upgrade package. I think upgrade is enough. Okay, it has updated rich from version 14.0 to 15.2. Okay, if you want to update a specific package, use the command uv log upgrade package and then specify the package name here. It could be a jax, could be numpy, anything. And if you want to upgrade all the packages inside this, then you have to then you write uv log upgrade, then it will upgrade the versions inside the log file to propagate those changes, right? Uv sync. Now it has become 15.2.2. This is how you update the packages inside the uv managed virtual environments. Now we have to see one more thing here, installing the current package in an editable mode. We'll see this one. So let me create some set of files. I have written a bash script for this. Okay. You do not need to learn this, just avoid it. Okay. And let me create a set of files. Okay. Where is it? Okay. Change to qvdemo. Bash index.sh. Okay, it has created some packages for me here, the same one that you have seen in the earlier videos. Okay, now you have to, let us say you want to access package 1, package 2, package 3 inside your modules. I have here. No, let's say module 1, not module 1. Let's say I call it as okay, maybe what should I name it? Say I'm giving a random name. Okay, this is a, let us say this is just a module document. Okay, here I want to access I want to do import package 1 from package 1. I want to import module 2. So this should let's say I also define a function, define the main.py, okay, which prints this is a main function, this is the main function from src/package/. Let me code this in string. Yeah, now you get it. No, okay, let's see if we'll be able to install, we'll be able to access it or not. I think it has demo. I'm checking for the version. Okay. Let's run this and module 2 and call the function module2.main. Okay. No. Python src/index dot src/module.py. You are able to access it. This is because uv demo. Let me uninstall this. uv pip uninstall uv demo. It's not installed. Okay. Yeah, we're inside the package 1. This is working because of the relative import. Package 1 is directly inside. Let's say I'm inside the package 5 and doing this. Now you get the problem, right? src/module, sorry, package 5. So I'm trying to access what? So I'm inside the package 5. No, it's in the same it's in the same project only. I'm inside the package 5 and I'm trying to access module 2 from the package 1. So, but it is not letting me do this because so like, you know the reason from the last video we have seen, because this one is not in it. The package 1 is not inside the path of this file. So to solve this, what we will do, we will do uh, we will install our current project as a library, or as a package inside the uh, inside the which inside the virtual environment. Then you can access it. So to do this, you have to provide the build information here. Let me take the build information here. So you have to write build system. By the way, you don't have to remember this syntax. You can get it online. Let me show you how to get this. Build hatchling build pyproject.com syntax. Okay, let me paste this. I want hatchling.build and I want to, I'm specifying the build information, tool.hatch.build, targets.build, tool.hatch.targets. What's this? Yes, this one. Tool.hatch.build.targets.ss. Okay, now I'll specify only the wheel. Okay, packages. No, I'm saying include src everything. I prefer using the include syntax because it supports this globing pattern. Include and strip away the path src sources is equals to src. Strip away the src and install these 5 packages. So now I have provided the build information for it. Then you can install uvpep. Then write uvpep install in an editable mode the current package. I want to install the current package as a I want to install the current project as a package in the virtual environment in an editable mode, meaning any edits that I make to the project should be immediately available here in the project. So if you don't do the editable, if you don't give the editable flag and directly install it, first it is building the file. Okay, let's build it. Now it has installed a UV demo. We can see that here UV library, and you will get it here, UV demo. Okay, it's here, UV demo. This is the distribution information here, and we have only, remember, so you see, include whatever is in the src. Okay, include whatever is in the src, but strip away the path src. It includes the whole src folder, this src folder, and strips away the path. So when src is stripped away, only package 1, package 2, package 3, package 4, package 5 are available. And you can see that package 1, package 2, package 3, package 4, 5 here. Okay, since these are available in the side packages, you can directly do it. And you can, this will work now. Let's run the same command. Python. Okay, now I understand. Hey, do you see this? We haven't activated the virtual environment yet. Okay, let's activate it. Virtual environment script /activate. Okay, now run this. Now you see it's working. Okay, we haven't done this with the let's say then you might get it out that it could be because of the global Python interpreter. Okay, for you, let's do it again. UV-pep. Let me uninstall the UV demo project, UV demo package. So it has removed it entirely, and you can see that you don't have a package 1, package 2, package 5 here. You don't see anything here. I mean the P section. Yeah. Now run the same command again. You have encountered an error. So to resolve that, we have to install this one. uv pip install the current package. uv pip install. So it's saying, hey, look at this current location. In this location, you will find a pyproject.toml file. Look into it. You will get the build information here. And from that build information, install the packages, build the from that build information, construct the wheel file. From that wheel file, extract the packages and place inside the .venv side packages so that I can use that. Okay, and you can do, now you can do this. Let me install the uv demo and run it. Now I'll run it. uv python src slash package file slash module. So module.py. Now we don't get any error like this. Now we are able to. But there is a one problem with this. Our edits will not propagate immediately to the site packages folder. We'll see how to resolve. Okay, now I added a new statement here. I have edited the main function. Let's see what happens. Will it be able to print that? And you see that we are not getting this third line log here. So this is the problem. Any changes that you make won't propagate to that virtual environment package you have created. So to solve this problem, just type uv pip install in an editable mode doc. And now it will install this in an editable mode. Now write this. And now you print the statement 5 another times, you get it. So the changes are immediately propagated. And there is another advantage. You can, let us say, okay, like you can do whatever, like whatever it is getting exposed from the build file, so whatever this build file exposes, like we are exposing all these packages. Tomorrow you can do this one. Okay, let me create uv demo and do this. So we have a uv demo package inside the src, and you can do from the module file, module, you can write from package, not from the package one this time. You have to write uv demo dot package. Okay. Okay. UV demo. Now you can see wherever you go. Let's say I go into the module file and I try to access from uv demo dot project one, uv demo dot package one dot module two. So let's say I import this as UPPM as UPM, and in UPM I want to call the main function, and let me run this UV copy path Python, this one. Okay, you get it here. So you, from any module inside your package, can easily access it by following this syntax. Okay, from the main, from the package, like you can access it from, write the root package name, then from there trace it all the way to the module that you want to import. This is a very a very comfortable way of writing the imports. It lets you do this. Um, yeah, this becomes more useful while you are developing the projects and you're testing it during the development. Now, because now this allows the modules of your own package, sorry, modules of your project to import the modules of your own project, right? That's it. We have let's go back and check what we have done so far. Um, by the way, we'll have, yes, I forgot to mention one more thing. The next time, let's say I have removed the VM. Okay, so now it's a clean project. So if you clone the project from the GitHub, you'll get like this. So if you wanna, let me deactivate the current. Okay. Now, next time, when you want to set up a project, okay, if you want to set up a project, directly write, like if you were like this, UV sync editable. First one, UV sync is for installing all the packages mentioned in the pyproject.toml with the versions that uv.log gives you. Second, the editable is for, hey, install my current project in an editable mode. And this will do it for you. Okay, and you got it here. Let's say you add any pack, you add anything later. Let us say I'm adding pandas. This will automatically update it and will update your build file of your project and push it into .env side packages. Okay, that's it. Yeah, let's look at what we have done so far. This one, I have mentioned all the commands that we have used today here. Wake install, and yeah, so we have seen. Okay, I think somewhere we got deviated. But there are two other things. I will let me do it. Let us say there is another way of running this. Package file. This is demo project. Where is UV demo? Okay, here it is UV demo. Okay, now I want to. There is another way. So far we have been running it with the CLI tool, and we have first one. We have configured it in the CLI that activate. Forgot to activate virtual environment anyway. Now, by the way, UV add, UV removes works even if you do not activate virtual environment. Next, we have configured this one. We have configured the interpreter here for the pylons interpreter. There's another way to run this file. You can run it using, let me go here. Eraser, where is it? Okay. Next one is Jupyter extension. With the Jupyter extension, notebook runs. Okay, Jupyter extension run. Three. The other one is when you are running inside a notebook that is having IPynb extension. So this one. Okay, we'll see the other two now. Okay, so I have installed Jupyter extension. Jupyter. So you can find Jupyter here. Yeah, this one, this Jupyter extension. This will allow you. This will give you an option to run the. This will give you an option to run this file using run in an interactive window. Okay. Now, obviously, this should throw an error now to us. Let me wait a minute to let it connect to it. Mm, let's say I write this code. Let me module scripts.ipy. So there is an you can create a file using like this. No. Let's see what's happening here. Hey, it didn't work. Let me restart the kernel. Let me do it again. Okay, as expected, it should throw an error evident. Why? Do you see the top right corner here? What is it saying? It is using the kernel. Sorry, it is using the global Python, C Python, this one. So but our virtual environment interpreter is different. So we must set the interpreter to select another kernel, Python environments, this one, the current one, UV demo. Set it to UV demo. Now you can, okay. So to run this in this kind of interactive window, this needs to install some Python packages. Let it install. It will install all the packages. You will see those packages propagating here. Right, it's getting you're getting new packages getting installed here. And okay, let it install. A few more minutes. In between, let's discuss this one. So when you write code in this kind of notebooks, you have to select again in the top right corner of this notebook. You have to select the kernel. Again, write Python environments UVDEM. So went from select another kernel. Sorry. Select another kernel. Python environments UVDEM. Okay. Now you will be able, you have to change the interpreter here, by the way, to this current interpreter which we have, python.exe. Okay, then run it. Let's run it again. It behaves weird sometimes. I don't know why. Let me restart it here. Copy the bar. I do one thing. Present working directory. Let me take Windows style CYG. I want it in Windows style. Okay. Let me open the window again. Sometimes it behaves weird. Go to Visual Studio Code. I want a new window. I'm opening the same window again. Open folder. Open this folder. Okay. Let's see this one. Okay. We have to run module 3, module 5 plus module.py, this one. We want to run this in an interactive window. Run this in an interactive window. What's happening? Okay. Let me run this at least. skip the video if it lags too much. Okay? Yes, obviously it should throw an error because we have configured a different interpreter here. Let's select the right interpreter first. Okay, now let me run it. Module.py, run file. Now you get it right. Why? Because we have set a different interpreter here. So whenever you run your files in an interactive window, remember to set the interpreter of this virtual environment. This interpreter that you activate here, this doesn't matter because this is for CLI, and the one that you set here at this bottom right corner, let me go to, okay, this bottom right corner, the one that you set here is for the pylons interpreter for checking your syntax, teleporting you to the files for that one. This CLI is for this interpreter is for the CLI only, so you are activating it here. This is for CLI, and you can this updates the like Python that you now this Python executable is this Python, and when you are running it in an interactive window, okay, when you're running it in an interactive window, you should set the interpreter right here, okay, and it will work as it works here. But yes, there are some advantages. You'll be able to see the history of every runs, and it becomes very useful when you're working with matplotlib and so many plots plotting in your plotting in the program, all of that. It will be convenient to have it here, so that's why I'm using this one. If you're not executing it in a notebook, then let me restart it. I know what's wrong. You have to set the interpreter again here. Set the interpreter to this one. Scripts python.exe, this one. Okay. If you are unable to find it through here, just enter the bar and done. Okay. Then I don't know what's interrupt. Okay, let me again come back to it. Code delete and then let's start it. I don't know what's wrong. Okay, let me try to run this. Something is up. VS Code sometimes behaves weird, and I think I have been running the computer from a long time. It's hanging. Let me reopen the window again. So open folder. This location. This one. Let it detect the kernels first. I'm not going to interrupt this. Okay. Now let's run this. You got it here. Let us say I change the interpreter to something else. Will it run again in that case? Okay, install all the packages it needs. This notebooks installs specific Python packages like IPY kernel and so many things. It will install in your, okay, it's saying, hey, running cells with Python requires IPY kernel package. IPY, install IPY kernel into your course install. Okay. And let me change it to global version. Python environments, C Python 14. Okay. Something is up again. So it is saying UV demo is not found because we have configured the global Python interpreter. In that global Python interpreter, it doesn't have our package. So to solve this, put our package. Now you will get it. I hope you get the idea. So we have so basically in the four different places. The first one, the command line interface. Second, the pylons, Jupyter extension, that interactive notebook run, and the notebook. Okay, you have to ensure that you configure the right interpreter, which is the virtual environments interpreter. Okay, next one. Okay, let's take a visit to what we have done so far. S4, okay, S3. Okay, we have learned UV as a package manager. We learned how to create a virtual environment, then configuring the interpreters in VS Code. In the next video, we'll see how to distribute our package and how to set up a package, how to set up a Python project locally using UV. All right. Practice it well, and yeah, I'll see you in the next one. Bye. Bye. Bye.